Hi, I'm Mr. B. After watching this lesson, you will be able to identify ionic compounds and explain the process of ionic bond formation. Consider the binary ionic compound, magnesium fluoride, MgF2. Magnesium fluoride is a binary ionic compound because its formula contains the ion of a metallic element and the ion of a non-metallic element. Magnesium fluoride is a binary compound because it contains two different elements, magnesium and fluorine. During the process of ionic bond formation, the metallic element, in this particular case magnesium, will lose its two valence electrons, and the two non-metallic atoms of fluorine will gain one electron each. The process of losing electrons is called oxidation, and the process of gaining electrons is called reduction. So during the process of ionic bond formation, electrons are transferred from the metallic element to the non-metallic element. The process is better illustrated using Lewis dot structures, where for magnesium we write Mg. A Lewis dot structure consists of the symbol of an element and its its valence electrons. In this particular case, there are two. For the fluorine atom, we write F and 7 dots, since fluorine contains 7 valence electrons. When magnesium transfers its 2 electrons to fluorine, the magnesium atom becomes a positively charged magnesium ion called a cation. So we write Mg plus 2. The magnesium atom becomes the magnesium cation with a plus 2 charge because after losing its 2 valence electrons, its nucleus will contain 12 positively charged protons surrounded by only 10 negatively charged electrons. Thus, the net charge will be plus 2. When each fluorine atom gains an electron, they will form the fluoride anion, where anions, or negatively charged ions, will always be written with an octet of electrons shown. Now, I say octet of electrons showing because we actually write them for the negatively charged ion. However, for the cation, it doesn't show any dots for valence electrons. However, if we now look back at the Bohr model, after losing its valence shell, the magnesium cation will indeed possess an octet of electrons as well. We simply don't write them into the structure. The fluoride ion formed after gaining 1 electron each will be placed in brackets and the negative charge written outside of the brackets. So let's review. During ionic bond formation, the metallic atom will lose its valence electrons. In this particular case, magnesium has only 2 valence electrons to lose. The electrons lost must be gained by a non-metallic atom. In this particular case, fluorine, which has 7 valence electrons per atom. After gaining 1 electron, we produce the fluoride anion that has a negative charge. Since the formula for magnesium fluoride is written as MgF2, we will produce 2 fluoride anions, and of course 1 positively charged magnesium cation. At this point, the positively charged cation and the negatively charged fluoride anions will attract each other electrostatically to form an ionic compound. And the ionic compound is written as follows, where we write the cation in the center, surrounded by the two fluoride anions. Remember, the ion of a nonmetal will always possess an octet of electrons. And we write the charge for each anion outside of the brackets. This represents the Lewis dot structure, or a dot diagram, for the magnesium fluoride molecule. Magnesium fluoride is also called a salt. A salt is simply an ionic compound. Since magnesium fluoride is a soluble salt, it is also an electrolyte. Electrolytes are compounds that will dissolve in water, creating an aqueous solution that will conduct electricity. The chemical formula for magnesium fluoride is written as follows: Mg plus 2 F minus 1. Since the oxidation states do not cancel, we must crisscross to produce the chemical formula MgF2. It is important to remember that ionic compounds, or salts, will join together in their ionic forms to form a crystal that is very stable. Therefore, ionic compounds will have very high melting points. And when dissolved in water, ionic compounds will conduct electricity since they are electrolytes. Comparing electronegativity values is another way of determining whether a compound is ionic or not. If the difference in electronegativity values is greater than 1.7, then the compound is indeed ionic. For the element magnesium, the electronegativity is 1.3. This information may be determined from a table of electronegativities. For fluorine, the electronegativity is 4.0. Subtracting 1.3 from 4.0 will yield a difference of 2.7. And 2.7 is greater than 1.7. Therefore, the compound magnesium fluoride is indeed classified as an ionic compound. But what if you're not sure whether the compound is ionic or not? Suppose the formula contains an element, an atom, or an ion of a metalloid or semi-metal. For example, consider the compound antimony 3 chloride. Antimony 3 chloride has a formula that is written as SbCl3. If you recall, metalloids possess properties or characteristics of both metals and nonmetals. In order to determine whether a compound containing a metalloid is ionic, we must compare the electronegativity values. The electronegativity value for antimony, Sb, is 2.1. And the electronegativity value for chlorine, Cl, is 3.2. 3.2 minus 2.1 is equal to 1.1, which is less than 1.7. Therefore, the compound antimony 3 chloride is not an ionic compound.